All right, so here we go. I'm going to start the next day of the last section that we're going to go over. So we're on day 3. Today what we're going to do is determine the area underneath the curve. So very similar to what we've been doing the last couple of days. It's just it's graphs now, not just equations. So we have to kind of remember what does the integral mean and how does it work. So let's go ahead and jump right into it. So I'm going to zoom this up so we can kind of see a little bit better. So if we want to find the area of this shaded region, remember the integral, the definite integral from the start to the finish can do that. So the one thing we know about this curve follows this equation. So if we want to find the integral, we have to kind of know 3 things. We got to know the equation that we're looking at, the bounded equation, which is this x minus x squared. And then the other 2 things are our starting location, which is here at 0, and then our end location. Now, what we normally would do, or if we were doing this a long way, we'd write it out as an integral and bump the function up and plug in the top number, plug in the bottom number and subtract them. But since we can use a calculator, just want to double check that you guys can see this calculator. Yeah, you guys can see that. We're just going to go ahead and plug things in. So I'm going to clear this off. Remember, we can press math 9 to get the integral. So our start is, well, we start right here at 0. Our end is at 1. We're always looking at the x-axis. We could potentially look at the y-axis if we are shading left to right, but that's a section of this chapter that I skipped. Gets a little tricky. And then we're going to just type in the bounded equation. And it's going to be x minus x squared. And then we have to put a dx at the end here to let the computer know we're going to shade up and down. And press enter, and I'll move this out of the way. And there's our answer. It looks like 1/6, which if we ever wanted to get an exact answer, we could press math, enter, enter. But I think we're going to type in the decimal, so we round to the 4th decimal place, so 0.1667. All right, now this is nice and easy. We're going to keep it because everything is on the x-axis. If we were ever off the x-axis, we'd have to do a little bit of subtraction, and we might see a problem like that tomorrow. I kind of forget. I think I actually got rid of that because we're doing the distance learning. Okay, so we'll go through this, and you'll see we got to find those same 3 things. We're going to type in our start, which in this case would be at 1, our finish, which would be 2, and the bounded equation. Now, if we want to, we can just do it here, but you know, I'm going to do this on the y equals just to show you again another way we can do this. So we can type in the bounded equation, y divided by x squared. Oop, I got to put that in parentheses because it's on the denominator. Could graph that. Does that look? All right, and then remember on here, if I do second calc and 7, so this is just another way. This is the exact same thing as the math 9. It's just graphically. I can type 1 as our lower limit, 2 is our upper limit, and it shades it in exactly the same way that our graph looks. It's just our window's not as zoomed. And we get an answer of 0.5. Just to show you again on that problem, if we did it here, we'd press math 9. We went from 1 to 2 of 1 divided by parenthesis x squared. Close the parenthesis, dx. 0.5. So sometimes graphically, I don't know if you're just a visual person, it's easier, but if you understand what's doing, this is a lot faster here. Okay, next one here. Okay, we got cosine. One thing, just be tricky here. We are starting at 0, going over to pi over 2. So we can actually type that straight into the calculator. I'm going to check my calculator to make sure I am in radian mode, which I am. And I'm just going to do the math 9. So math 9 to get the integral. Our equation starts at 0. We're going to pi over 2, so we're just going to type in pi divided by 2. This would be tough if we were just doing this on paper, but since we can use the calculator, we can make it, figure out the number. And we're just got cosine of x. We have to close a parenthesis for that. There we go. Everything's inside the 1 parenthesis, dx. Press it. There we go. That would be 1. And that would work out. If you remember, if we bump up cosine, that would bump up to sine. And we plug in pi over 2, sine of pi over 2 is 1, divided by sine of 0 is 0, 1 minus 0 is 0. So we could still do this the long way. All right, here's one that wouldn't be fun to do the long way, but we'll do it the easy way. Okay, we got x plus sine over x. And we're starting at 0, we're going to pi. So this stuff isn't too bad if we know how to use the calculator. All right, math 9, 0 to pi. We're just going to type that in using the pi button. And the equation is x plus sine of x. Got to close that parenthesis. Dx. Enter. Okay, we get 6.9348. Okay, which kind of makes sense because x would go to x squared over 2. Sine would go to negative cosine. Probably would come out a little bit weird. Okay, well, let's see how well we did. I always like to double check these now. This is my answers. All right, 4 out of 4. So today is short and simple, really easy. If we want to take a look at what we're going to do tomorrow, bounded region. So it's going to be very similar. What we're going to do tomorrow is we have the equations. We just don't know what the start and finish is unless we graph it. So tomorrow what we'll do is, if you want to get ahead, you can go through and type these equations into Desmos. And then you'll see it will make like a little box, a little region that we'll just go through and do what we did today. We'll figure out where does it start, where does it finish, and what's the bounded graph. Usually they complicated. And we'll type it into the calculator. So only 3 problems tomorrow, so not too bad. And yep, I don't see any of the tough ones. Okay, any questions?
No.
All right, well, great as always. Have fun. We'll see you tomorrow. Have a good one.
Thanks.